Okay, let us find the area of an ellipse here. Let's see. So an ellipse, we're going to assume that our ellipse is centered at the origin. So that would give us the formula x squared over a squared plus y squared over b squared equals 1. Okay, now the ellipse has symmetry, so we'll just find the area of the upper region. And so if you take this formula and solve for y, you'll actually get y equals plus or minus, but we only want the plus portion. So you'll actually get y equals plus or minus b over a times this radical, but you only want the positive portion because we're only going from we're only getting the upper region. So this is the upper region here of the ellipse, and then we're only going to go from 0 to a because a would be that axis. Now since we're only going to go from 0 to a, actually instead of getting the upper region, we're going to get the upper quarter. So basically if we just integrate from 0 to a this function, that will only give us a fourth of the actual area. So to get the actual area, we'll multiply this by 4. Okay? So now, so the main thing is I got to figure out how to evaluate this integral. So what we're going to do is we're going to let, since I have a squared minus x squared here, I'm going to let x equal a sine theta, because that's the trick you do when you have a squared minus x squared. And then dx would be a cosine theta. Okay, now, so while we're doing that, let's remember, since we're integrating as x goes from 0, then let's see what theta is when x is 0. So when x is 0, then theta would be 0. And also, if x was a, we could put a in here for x, and we would see that sine of theta equals 1, so theta would be pi over 2. So basically, that means we're going to be integrating from 0 to pi over 2 on our theta variable. Okay, so we needed to know that so that we would know what limits to change to since we changed variables. Okay, and then back to a squared minus x squared, we know that's going to equal a squared cosine squared theta. So now let's plug in what we know here. We can replace a squared minus x squared with a squared cosine squared theta, and we can replace dx with a cosine theta, d theta. And then that's going to equal, looks like I didn't put the equal there. Alright, so that's going to equal 4, and I factored the b over a out, so 4 times b over a. And we're integrating now. Since we switched to theta, remember we're going from 0 to pi over 2. And now let's see what would happen here. So if I take this out of the square root, I'll have a cosine theta, and then times another a cosine theta. So that would give me a squared cosine squared theta, d theta. Okay, now if I multiply, let's go ahead and multiply the 1 over a back through. Let's see, is that what I would get? So if I multiply that back through, that's not right. Okay, sorry about that. I just now figured out what I did. If you factor the a squared out here, and then divide the a into the a squared, that would give you an a in the numerator, so that would give you a 4ab. So that's where that 4ab comes from. So basically, you know, a squared over a is just a. So you have 4b times a, which is 4ab. Okay, now all we have to do is evaluate this integral cosine squared theta d theta, and we can use our identity 1 plus cosine 2 theta over 2. And then if I pull this 2 out over here, then I can divide the 2 into the 4ab, and that'll give me 2ab. and then I'll have in here the 1 plus cosine 2 theta d theta. So that's going to give me the 2ab, and of course when we integrate the 1 with respect to theta, we get theta, and when we integrate cosine 2 theta with respect to theta, we're going to actually get sine 2 theta divided by 2. And we're going to evaluate this from 0 to pi over 2. Okay, so let's see what would happen if I evaluate this at pi over 2. So if I evaluate this at pi over 2, I would get, let's factor the 2ab out so it's out of the way. So now, the 2ab, and then let's do this here. So if I evaluate this at pi over 2, I get pi over 2 plus sine of, what's 2 times pi over 2? Sine of pi, right? So sine of pi is 0, so I'd get pi over 2 plus 0. And then minus, now let's evaluate at 0. Well, if I evaluate this at 0, I get 0. And if I evaluate this at 0, I'm going to get sine of 0 over 2, so I'm going to get 0. So when I evaluate it at 0, I just get 0 plus 0. So finally, I get pi over 2 plus 0 minus 0, which is just pi over 2, and then multiply by 2ab. And so 2ab times pi over 2, the 2's will cancel, and then I get just ab pi, or pi times ab. So now let's apply the formula. So now what's the area of this ellipse? Okay, well, here a would be the square root of 9, which is 3. B would be the square root of 4, which is 2. So the area of this ellipse would be pi times AB. So AB is 6, and so pi times 6 would simply be 6 pi. Okay, so there you go. Now you have the formula for the area of an ellipse.